Okay, so anyway, what this will do is it'll say, I want you to prove that both pairs of opposite sides are congruent, and it'll give you that ABCD is a parallelogram. Okay, so let's just write that part down first. ABCD is a parallelogram. All right, and this is going to be given. So ABCD is a parallelogram, and you draw the diagonal. Which one did I draw? Did I draw diagonal BD or AC last time? Did I draw it this way? I drew it that way? Okay. Okay. Let's just to keep it consistent with the last one we just did. There's your diagonal. Okay. ABCD is a parallelogram, and that is given. And then that automatically means that the triangle ABD is congruent to triangle CDB by theorem 1, because we just proved it, right? Okay, now how can I prove that opposite sides are congruent? Well, I'm saying that the triangles are congruent. If the triangles are congruent, what has to be true? Well, that forces the opposite sides, BC and AD, also AB and CD, that forces those to be congruent. So that's by CPCTC. Does any of that make sense? All right, what I don't like about this is that the marks were already made. So, and I think that might be, that might mess you up a little bit. So if you can imagine these pictures without any marks, that's probably the best way to do this. All right, so both pairs of opposite angles are congruent. That's what we want to try to prove. Okay? This is what we want to try to prove. So right now, we're just given that ABCD is a parallelogram. If ABCD is a parallelogram, we can still draw a diagonal, and we could prove that the two triangles are congruent, but we've already proven it. So we're just going to say that triangle ABD is congruent to triangle CBD. I'm sorry, CDB. And we proved it congruent. So we know that if it's a parallelogram, the two triangles are congruent by theorem 1. Okay, so now what do we do? If the two triangles are congruent, what is also congruent? Everything is, right? But in this case, in particular, what's congruent? A with C. Angle A is congruent to angle C by corresponding parts of congruent triangles are congruent. And then I'm just going to write a little note down here. Angle B and angle D can be shown congruent by a similar proof. What would be the only difference between that proof and this proof? Well, I'd have to draw the diagonal the other way. So if I drew the diagonal this way, y'all follow me? If I drew the diagonal this way, then I could say that angle B and D are congruent by corresponding CPCTC. Say it again. Oh yeah, triangle ABC. Yeah. they would be different triangles, right? All right, so consecutive angles are supplementary. We have to make sure that we're going to prove that consecutive angles are supplementary. So angle ABCD is a parallelogram. And you know what? I don't think that I would actually even prove this one. Well, let's pause on that one. All right, so we're going to skip the consecutive angles one for now, and we'll come back to it another time. So the diagonals bisect each other. Well, okay, same thing. We're given that ABCD is a parallelogram, but this time we actually need to start looking at these two triangles, right? The one on the left and the one on the right, or the one on top and bottom. Say it again. Yeah. We're going to use that vocabulary word pretty soon. So this time we're given that ABCD is a parallelogram. Well, but we're trying to prove. Let's call this X. This point up here in X. Okay. Do y'all understand that if I can prove this shaded triangle is congruent to this shaded triangle, then that means, if those two are congruent, then that means that the corresponding sides are congruent. And then that means that opposite sides would be congruent, right? Okay. So you guys keep saying vertical, so let's go on and actually talk about that. So angle AXB is congruent to angle DXC by vertical angles. I'm with you there. Boom and boom. That's the two angles that you were talking about, right? So now we can say that the left triangle is congruent to the right triangle. Or I shouldn't call it a right triangle, but the triangle on the right. All right, so triangle AXB is congruent to, make sure the letters line up right, AX, that has two marks on it. So I need to say CXD, right? CXD by what theorem? There's a side there, and an angle there, and a side there, so side, angle, side. All right. So what must be true? If we just proved the two shaded triangles are congruent, what has to be true? All of them have to be. So including which one? AB and CD. They have to be congruent. AB is congruent to CD, right? By corresponding parts of congruent triangles being congruent. All right, well, what else do I need to show? Yeah, bless you. Bless you again. All right. So we've proven that one pair of opposite sides is congruent, right? I'd love it if we could do that one more time. Can we do that with this triangle and this triangle? All right, so how can we do that? Triangle BXC is congruent to triangle. BXC is congruent to triangle. What other triangle? DXA, yeah, triangle DXA. By what theorem? Well, triangles can't be congruent because of vertical angles. Yeah, so these angles are congruent by vertical angles, and technically we should say that first. Angle BXC is congruent to angle DXA by vertical angles. And then after that, you can say that the triangles are congruent by, come on somebody, y'all are going to get it. What is that? A side angle side. There it is. Best side angle side. And now you've proven that the top and the bottom sides are equal. So that means that BC, come out a little bit on the camera, means that BC, 1, 2, 3, 4 marks, BC is congruent to 1, 2, 3, 4, AD. Why are they congruent? CPCTC. Now, why is this thing a parallelogram? Huh? Everything is congruent. Yeah, but use one of those properties. ABCD must be a parallelogram because both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. And I think that's a safe place to stop, guys.
Yes.
You're like, yes, 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 yes. All right, cool. So I am going to give you a worksheet before you leave, okay?